All right, so we're going to find the graph of this and the range of this. We'll do the range too. And the first thing when you're given a function like this is I don't care for the way it's written. I much prefer to have it in slope-intercept form on both of them. So I would think to myself this. And if we know limits, we can check what's happening at f of 3, the limit, as you approach from the -1. When you come from the negative side, which is less than, which is this one, of f of x, we're going to plug -1 into this function, this polynomial, and I get that's 1. And then I'm going to check the limit as x approaches -1 from the positive side. And I plug in -1 here into this equation, and I get -1. I get this as 4. So the first thing I know about this graph is that it's not continuous. The left-hand and right-hand limits are not the same at -1. So when I make the graph here, I would set those 2 points, x, y, and because this is not equal to 1, this is an open circle. So at -1, 1, there's an open circle for that one. And I would put the closed circle at -1, 4, which is that one. And then I'm just going to graph 2x plus 3 to the left of -1. To the left. So to this side, I'm doing 2x plus 3. So, and this side, -1. So I see plus 3 here, and I'm thinking to myself, the line kind of looks like this. But I'm only drawing it solid here, because it's to the left of -1. And if I use my eraser and get rid of the dotted, all right, it would look like that. The other line is -x plus 3. So I have the dot up here at 4, and I'm thinking -x plus 3. So it goes through plus 3, and that's a slope of 1. And my graph's a little out of scale, but it's going to look like that. So this is the graph of the function. Since -1 is included, I can say the domain is all reals for both lines. Now the range, the only way to really do range of functions is to look at the graphs. And I can see it goes to -infinity and goes to -infinity, comes up, it's an open hole, but it's solid here, coming up. So the range of this is -infinity to +4, including 4. And we just graph this piecewise function of 2 lines. All right, so let's do another problem with a piecewise function. And again, there's a couple things I don't care for the way they organized it in the book. So I'm going to rewrite this as a line, and I'm going to write this as an inequality. So when I see this, I think to myself, it is -1 when x is less than or equal to 1, so it's a horizontal line. 3x plus 2, a positively sloped line between 1 and -1. If you need to practice this, you have to realize that it's a distance around the origin less than 1. So you go 1 each way, but it's not equal. So it's in between, so it's that inequality. And then it's x greater than or equal to 1 for -2x plus 7. And the big thing to realize here is that you probably could understand these two. Well, through thinking, you can sandwich the other interval in between. All right, so again, I would probably take a second and do limits, all right, on this piecewise. And I want to look at what's happening as I come to -1 from the left side. And when I come from the left side, it's just -1, right? It's just that horizontal line. And when I go in the middle function, when I come to -1 from the right side, I have to use this function. So I plug -1 in, I get -3. It is also -1. So I know that right now, this function is continuous at -1, which is kind of cool, okay? So it has an open dot, then that open dot gets filled. It has an open dot for this function, and then this function fills it because of the equal sign. All right, so now I would do the same thing with the limits on +1 from the left side of f of x, which is this function. We plug in 1, I get 5. Then I look at this function. I look at 1 from the right side. I plug in 1 to that, and I get 5. All right, this is a continuous function because each part is continuous, and the two limits are continuous. So I can graph this now. And I'm going to graph the middle section first between 1 and -1. I'm going to have to put the marks closer than that. We'll have to put another mark in. There we go. 1 and -1. And I know I got to get -1 to 5. So -1, 1, 2, 3, 4, 5. All right. I'll do it in red. I'm going to do this section in red. I'm going to do it different colors. So between, I can put 0 in. You guys agree 0, 2 is the intercept. And we know that it was 1, 5. And it was -1, -1. And this middle section, because it isn't equal, would look like that. Okay, in between, just a straight line. And then if I do this section in green, it's just a horizontal line, which fills in the circle because it's equal, and it just looks like that, which is -1. Right, horizontal line. In the last section, I'll do in black. I get 2x plus 7. So I can picture it going through 7 up here. I'm picturing the y-intercept, and it going down around the 2. And again, it fills in because of the equal sign on the inequality, and just has a slope of 2. And it looks like this. All right, the domain is all reals. That was set here, right? You can see that it set all those numbers. So the domain is all reals. The range is kind of interesting. This is just -1, and then it goes up to a peak of 5, and then it goes down to -infinity. So it's -infinity up to including 5. Again, this is a classic example. If you are to derivatives, there's a couple spots on this piecewise function that are not going to have derivatives, right? From the sharp points. Keep practicing. You'll get it. Get it.